Hello guys, in this video I will demonstrate you Gstreamer plugin that I have developed. So basically this is the low pass filter plugin, and I have developed using the 64 tab length. As you can see, this is the filter coefficients. So the array of the size of the array is 64, and this is the source code of the plugin. So let me go through the capabilities of the pad. So this is the sync pad and this is the source pad, and it only accepts the audio signals, and the format is floating 64 little Indian, and the number of channels are supported as 1 or 2, and the sampling rate is 48 kilohertz. So the filter that I am developed is the cutoff frequency for this filter is 10 kilohertz. So it will, like, this is a low pass filter and it will only allow the frequencies below the 10 kilohertz, and above the 10 kilohertz it will attenuate the frequencies. So this is the source code, and this is the chain function. So basically all the processing of the filter go on this function. I have implemented a convolution here. So in multiplication in time frequency domain is equivalent to convolution in time domain. Okay, so that's why I have to do the convolution here. So whatever data I got here, so I convert the filter GST buffer data into the character array, and not the character array actually, but the GST buffer data has a character array in it. So I have to convert it into a floating point array or double array. So I am doing the thing here, GST buffer extract duplicate. So this is out buffer, this is a GST buffer, and I am converting the buffer to the this is a generic pointer. Dest is the generic pointer. So I am converting it into a double pointer here in the convolution function. So this is the convolution function here, and it has a different implementation for the different number of channels. For the channel number of 2, it has doing convolution 2 times. For the one single channel, it is doing convolution only in single time, as you can see here. And I have developed the filter in the Python. So this is the Python notebook, in the Jupyter notebook. So as you can see, this is the low pass filter. It has cutoff frequency 10 kilohertz here, and it doesn't go to Z0 value at above the 10 kilohertz. So it has a value around 0.1 here, and also it is not the ideally 1 here. So it has value 0.9 in the passband frequencies. So this is not the ideal filter, of course. We can improve it a lot, but I have using the Blackman window to reduce the ripples. This is the Blackman window coefficients here, and this is the SINC coefficients. This is the coefficient for the low pass filter in the time domain, and as you can see, this is the 64 length of the filter. Tap length is 64, and I am using 512 for the better frequency resolution in the FFT part, so that it can give the better visualization of frequencies. Okay, and the better resolution. So let me show the demonstration here. So this is the demo application, and this demonstrates how we can use the filter in our Gstreamer application. So basically what I am doing here is I have developed the pipeline here. So it accepts some MP3 file, and after filtering it, then it playback that onto our speakers. So this is the pipeline. Firstly, it has a file source, the location of the file in our disk, and then it passes the data using the audio parse. Then it decodes it using the MP3 decoder, and then it resample. We need resampling because in our filter we are using the 48 kilohertz. That's why it is resampling. So if any of the data, like if the file has different sampling rate, so that it can convert the sampling rate to our sampling rate that we are using in our filter. And we also need the audio convert, because audio convert we need because we are using the floating 64 little Indian. So if this port, like in the MP3 file, if they are using the signed 16 bit, so they can convert it to floating 64 bit. And after the filtering, we are also using the audio convert and audio resample, because so to like support like whatever the sound card we are using in our system, so what formats and what sampling rate this port, so that it can convert to that sampling rate. That's why you're using the audio convert and audio resample after the filter too. And this is the sync. The basically sync what do is it like playbacks the data onto our speakers. So we set the pipeline to play here, and we are checking for any error messages here. Okay, let me show the demonstration as well. So you can compile the I have in this one main.c file that I have shown you in the source code, and a number of files like mp3 files here. You can compile the file using this command, and make sure that Gstreamer environment variables are in your path, and also the GST plugin path for which give the location where the .so files of our plugins, so that it can use the SO files there, and it can link to that SO files. After compiling it, as you can see, it compiles successfully. Then we can run this filter demo application. So let me use the file.mp3. So as you can see, it has little distortions there, because distortions are obviously it will present, because this is not the ideal low pass filter. So obviously there will be some distortion. We can improve the filter quality by using different windows and like using different techniques in digital signal processing, but that is not the goal in this video. The goal in the video is to show how we can integrate like DSP in the Gstreamer plugins, so we can use other techniques as well. So yeah, that's all for this video. Thank you so much for watching this. See you soon.